Hello everyone. Today's lecture is going to be about clustering analysis. Clustering analysis is a popular data mining technique used to sort your observations into different clusters or groups that are homogeneous according to the attributes of your data set. Separating your data set into clusters of homogeneous records is useful for improving the performance of the different supervised methods that you can apply on these clusters separately rather than on your heterogeneous data set. Clustering has a vast variety of business applications, from customized marketing to industry analysis. So the way we're going to structure this lecture is that we're going to first introduce an example, which is the data set for 22 public utilities and the different attributes for each of these utilities, and then we're going to try to see how we can divide these 22 utilities into clusters based on their similarities or dissimilarities. We're also going to introduce two different approaches of clustering analysis. The first one is the hierarchical clustering method, and the other one is the k-means clustering. We'll first introduce the topic of clustering analysis and what are the different applications of clustering analysis. Then we're going to work with this data set that you see in front of you right now, and how do we start the process of clustering analysis. So it might be divided over multiple videos. The first video is going to cover on how we calculate the distance between each of these observations, and based on these distances we're going to divide this whole data set into clusters, and then we're going to look at how to calculate the distance between the different clusters that we have just formed. So the whole lecture is going to be divided into multiple videos so that we can focus on one subsection of this topic at a time. To start with the introduction of the topic, like I mentioned before, clustering is a popular unsupervised learning technique used in data mining. We describe two popular clustering approaches in this lecture. The first one is hierarchical clustering, and the second one is k-means clustering. I've also provided some lecture notes for you to refer to while you're listening to this lecture online, and you can read the notes which might have a little more detail on these techniques that I'm talking about, and you will see the formulas that we're going to be using in this particular example in those notes as well. We're going to see how each of these clustering techniques work, and we're going to see the results of each of these clustering techniques, the two that I mentioned earlier. Clustering analysis has a bunch of applications. It is used to form groups or clusters of similar observations based on several measurements made on these observations. So what you see in front of you is the data for 22 utility companies, and the measurements of these utility companies are given in the columns here. So we have 8 attributes that have been measured for each of these 22 utility companies. Now, this idea of grouping data or clustering them together has a lot of applications, especially in marketing, where you can use it for market segmentation. Customers are segmented based on their demographic or transaction history information, and you can have a marketing strategy tailored for each segment. Another use of clustering is for market structure analysis. So you could identify groups of similar products according to the competitive measures of similarity. For politics or for the public sector, clustering neighborhoods according to lifestyles could be useful to identify what each of these neighborhoods require in terms of urban requirements. In finance, clustering analysis can be used for creating balanced portfolios where you try to identify the clusters of investments or securities that are similar to each other or dissimilar. Clustering analysis can be applied to huge amounts of data as well. So for example, internet search engines could use clustering techniques to cluster queries that users submit. That is beneficial because if you know that these queries are similar, they fall in the same cluster, you could return the same search results for any of those queries when they come up next. So typically the basic data used to form clusters are in the form of table of measurements on several variables, where each column represents a variable and each row represents an observation, which is what you see in front of you right now. Each row is for one utility company and each column represents a variable that has been measured for each of these utilities. Now, we can think of clustering analysis as a more formal algorithm that measures the distance between records, and we're going to form the clusters based on these distances. Now, there would be two types of distances that we're going to calculate through the course of this lecture. The first one would be the different distances between these observations, and the second one would be the distances between the clusters that we form. So before we introduce the concept of hierarchical clustering and non-hierarchical clustering, let's take a look at how our data is distributed across these different variables or attributes. Now, right now we have 8 attributes or 8 variables for our data set. Let's try to focus on just 2 of these attributes so that we can visualize the data and see how it looks and check if there is a possibility of using clustering analysis over this data set. So let's pick sales and fuel cost as the 2 attributes that we want to consider first out of these 8 attributes. And if we draw a scatter plot for fuel versus sales for each of these 22 companies, this is what the scatter plot will look like. And when you pay attention to the scatter plot, you'll see that there appear to be 2 or 3 clusters based on the sales and the fuel cost values for each of these companies. The first cluster, which is visible, is for the high fuel cost companies. There's a clear cluster of high fuel cost companies which have similar sales. And then the second cluster appears to be somewhere here for the low fuel cost companies but slightly higher sales, and another cluster can be seen for these high sale companies. So we can therefore think of clustering analysis as a measure of distance between these records, and the records that are close to each other would fall under the same cluster. Now, before we are in a position to put these observations into clusters, we have to first measure the distance between two observations. Now, in order to measure distance, we first have to define what we mean by distance. And we usually denote distance as a metric of dissimilarity between two observations. So how far away from each other are these two observations? And for any observation I and j, the distance between I and j would be given by how we have a vector of measurements. We can call that vector p, and based on this vector of measurements, how far are I and j from each other. In terms of this example, the vector p would be these 8 variables. So p is going to take the value of 8, and I could be Arizona, j could be Boston. So we want to find out the distance between Arizona Public Service and Boston Edison Company based on the set or the vector of these attributes or measurements. Now, distances can be defined in multiple ways, but in general, distances should have 4 properties, and those 4 properties include, the first one is non-negativity. So any measure of distance that you're using has to be positive, greater than or equal to 0. There should be self-proximity, which means that the distance of an observation from itself should be 0. So the distance between I and I should be 0. The third property is symmetry. Sorry, I cannot spell that. It should be double M and single T. Symmetry means that the distance between I and j should be the same as the distance between j and I. And lastly, the triangle equality. So triangle equality means that the distance between I and j should be the same as the distance between I to k and k to j added together. This is an important property that your distance measure should have. Now, one of the most commonly used distance metric is the Euclidean distance. The formula for that I've given in the notes that are available on Canvas, but we're going to apply that formula in order to see how the Euclidean distance is calculated. So what we're going to do is we're going to use the Euclidean distance formula for these 2 observations, Arizona Public Service and Boston Edison Corporation, to find out what the Euclidean distance for these 2 companies is, the distance between these 2 observations. And we're using all of the 8 attributes here. The way the Euclidean distance is calculated is you're going to find the difference for each attribute amongst these 2 variables, square up those differences, sum the squares of the differences, and then taking the square root of that sum is going to give you the Euclidean distance. By that I mean you're going to first subtract the value for fixed cost for each of these companies. Similarly, you're going to calculate the difference on rate of return for Arizona and Boston, the difference of cost for Arizona and Boston. Once you have all these differences calculated, we're just going to square them up and calculate the sum of these squared distances. Once we have the sum, getting the square root of this sum is going to give you a measure of distance between these two companies, Arizona Public Service and Boston Edison. So usually what happens is that this term, this measure on its own is not going to provide too much value to you unless you measure it to the same value that you calculate for, let's say, Arizona and a third company, Florida Power and Light. And if the distance between Arizona Public Service and Boston is less than the distance between Arizona and Florida, then Arizona and Boston would be in the same cluster and Florida is going to be in a different cluster. So that's how you approach the whole cluster analysis technique. Now, the difficulty that we face when we just use the Euclidean distance is that this number can be a very high number based on what variable or what measures you're using, especially because you're squaring them up and then taking the square root of those numbers. So this might be a very big number that you see, and it might be difficult to compare across multiple observations. So in order to get rid of this flaw of the Euclidean distance measure, we normally try to normalize these numerical measurements so that we can reduce the influence of scale on each of these variables. And by normalization, I mean calculating the z-score for each of these values. And we're going to do that with the help of this example on two of the attributes, sales and fuel cost. So initially, as you remember, we had 8 attributes, but for now, let's work with just 2 of them so that we can understand the concept of distance and normalized distances. So in order to calculate normalized distances, we would first have to get the mean and standard deviation of these attributes, and I'll calculate that here. Getting the average sales across all 22 companies and getting the standard deviation. Now when you try to calculate standard deviation in Excel, it's going to give you multiple functions that are available to calculate standard deviation. The P refers to population, the S refers to sample. So for in our case, let's assume that this is the whole population that we're considering, not a small sample of the population. So we're going to use the standard deviation P to get the mean and standard deviation of sales. And similarly, when I drag this across, I'm calculating the mean and standard deviation of fuel cost. So now let's try to calculate the distance between Arizona Public and Boston based on 2 variables, sales and fuel cost, by normalizing those variables first. So to calculate the normalized sales, I'm going to subtract each observation from its mean and then divide it by its standard deviation. Oops, sorry. There you go. So make sure that the difference between the observation and its mean is in brackets so that the subtraction takes place first and the division takes place after. Because the mean and the standard deviation remain the same throughout, I'm just going to convert those into absolute references. You can do that by pressing F4 on your keyboard. And I can drag this down to apply the same formula to all the 22 companies. The same way, I'm going to normalize the fuel cost for each of these companies, and for that I'll subtract each observation from its mean and then divide it by its standard deviation. Now, I would recommend for you to, while you're watching this video, that you open up the Excel sheet that has been provided to you. It's the same Excel sheet that I'm working on, except that you would have the blank cells here, which I'm filling right now. So when you work with me on the Excel sheet, you can see how you could apply those formulas yourself. So I can drag this down. Now I have the values for the normalized sales and the normalized fuel cost, and then we're going to move on to calculate the distance between two of our companies, Arizona and Boston. So the normalized sale for Arizona is given in cell D2, and the normalized fuel cost for Arizona is given in E2. The same way for Boston is given in D3, and for fuel cost is given in E3. Now, once we have these values for normalized sale and normalized cost between these two companies, we can find the difference. Drag this formula across. And once we have calculated the difference, we're going to square this up. And then add these squared differences to get the sum. And then finally, the distance would be the square root of this sum. So looks like the normalized distance between Arizona and Boston is approximately 1.99. Because it's a normalized distance, it does not have a unit, but we can get the distance between Arizona and all other companies here the same way. As a practice exercise, you can do that for the rest of the companies as well. I have added a tab here where I have already calculated the normalized scores for all these different attributes for all the companies that you can use in order to get the normalized distances. So the first section, where we learn how to calculate distances between observations based on variables, has come to an end. To continue with the lecture, move on to the next video. Thank you.